Hello, geometry. We are going to get started now with Unit 3. These first two lessons can be a little tricky. I planned some time to kind of make sure we get it. We will be using this stuff a lot, so make sure that you're at least trying to figure this out. So what we're doing today, I can identify the three types of angle pairs formed by a transversal, and I can use angle properties of parallel lines to find missing angle measures. So some vocab in there that you need to understand before we get started. I used one in the learning targets, a transversal. A transversal is a line that intersects two or more coplanar lines. So in this picture here, line T is your transversal. Okay, so you can see it, it's intersecting line L and line M, right? So that's what makes it a transversal, right? There are multiple types of angle pairs formed by a transversal. We're going to talk about three of them. All right. There are a couple others that we're not going to talk about, but yeah, we're going to jump into these three. Let me go ahead and clear this and move down a little bit. Alternate interior angles. In the above diagram, which angles are considered interior? So when I'm saying interior, I'm talking on the inside of the two non-transversal lines. So the two non-transversal lines would be L and M. Which ones are on the interior of those two lines? Well, it'd be angles 1, 2, 3, and 4. Those are all on the interior of those two lines. So which angles are considered alternate interior? So when I'm talking alternate here, I'm talking about the alternate side of the transversal. So I'm gonna go ahead and jump down here. On the opposite or alternate side of the transversal. So I'm gonna go ahead and erase the two circled parts here. So we're looking at angles 1, 2, 3, and 4. Well, if I look at this, 1 and 2, do you see how those are on the inside of L and M, but they're on the opposite sides of T? Those are alternate interior angles. So angle 1 and angle 2 are alternate interior angles. In the same way, angles 3 and 4 are alternate interior angles. Okay. Move on. Same side interior angles. Now we're still talking about the interior angles. So 1, 2, 3, and 4. Same side is talking about same side of the transversal again. You probably can figure this out from here, but on the same side of the transversal would be 1 and 4. Being able to identify these angle pairs is huge. 2 and 3 are also same side interior angles. All right. Corresponding angles changes things up a little bit. So I'm going to go ahead and erase everything. Actually going to make this a little bit smaller so I can try and fit it all in one picture. Which angles are considered corresponding? So the best way for me to explain corresponding is think of like two intersections. So I've got an intersection here and an intersection here. Okay. Corresponding would be the same corner of the intersection. So if I'm looking at angle 1, that's the bottom left corner of that intersection. What's the bottom left corner in the other intersection? That's angle 7. So angle 1 and angle 7 would be corresponding. Okay, angle 2, what goes with angle 2? Let's look where angle 2 is at. It's at the upper right. So angle 6 would be the upper right. All right. Angle 3 is the bottom right. So the bottom right would be angle 8. And then you can probably guess the last one, but angle 5 and angle 4. Those are all considered corresponding. Same corner of the intersection. All right. Notice how on all of these angle pairs, one of the angles is made by the transversal and line L, and while the other is made by the transversal in line M. Okay, what I'm trying to get you to see here is that one of the angles, for these all three of these angle pairs, one of the angles comes from this intersection and the other angle comes from this intersection. Okay, if you don't believe me, pause it and look back at this angle pair, this angle pair, this angle pair, that angle pair, and then all of these. Okay, they all have one angle in one intersection and another angle in another intersection. You will not see two angles come from the same intersection in this part of the lesson. Okay. All right, so classify each pair from the diagram. So angles 1 and 3. Angle 1 and 3, so I'm looking at them. Well, first of all, let's identify our transversal. I have two lines and they're both being intersected by this line. So the circled line is the transversal. 1 and 3 are on the inside of the two non-transversal. So therefore they are interior angles. They are on opposite sides or on the same side. They are on the same side. So I'm going to abbreviate same side interior angles. Okay. We'll go ahead and erase all the circled stuff here. Angles 5 and 6. So 5 and 6. Those are on the same corners of two separate intersections. Those are corresponding angles. Okay. 1 and 5. Those are on the same intersection. Okay. Make sure you're catching this. Those are not angles from this lesson. We've talked about these angles before, but imagine you could cover this up. There's nothing that's coming from that intersection. This is a problem from last unit. These are vertical angles. Right? They're not any of the three that we just talked about. That stuff is not going away. 3 and 4. Those are on separate intersections. They're on opposite sides of the transversal. So these are alternate interior angles. And on the last one, 1 and 4. Again, they're not even on this intersection. This is an old one. Those two make a line. They form a linear pair. We call those supplementary. Okay, so 3 and 5 were not from this lesson, but they're going to be in these pictures, and you have to be able to identify even those angle pairs as well. Okay, I know I'm asking you a lot in this lesson. All right, when a transversal intersects two parallel lines, now we're talking parallel, nothing on the front side, anything about parallel. Now I'm getting into parallel. Special relationships between the angles occur. And we've got three postulates or theorems here. If a transversal intersects two parallel lines, then corresponding angles are congruent. Okay, so make sure you catch the beginning of this. That's only true if the lines are parallel. Now, these two little markings here show me that those are parallel. Since L is parallel to M, we can conclude that angle 1 is congruent to angle 2. All right. Make sure you catch that this piece right here is extremely important. Okay. Next one, alternate interior angles theorem. If a transversal intersects two parallel lines, then alternate interior angles are congruent. Almost the same thing. All right. So I've got two parallel lines. Okay. That's actually given to me. A is parallel to B. I gave you that with the markings. Now, I'm doing this proof here to show you that this is always true. be able to follow along with this. Okay. Now, angle 1 is congruent to angle 4. So how do I know that those two angles are congruent? Well, I just talked about it. That was a corresponding angles postulate. Notice I'm abbreviating. You should abbreviate the same way. If you want to abbreviate, you can always write it all out. But if you're going to abbreviate, do it the way I do it here. So corresponding angles postulate says that angle 1 and angle 4 are congruent. Recapping what I did just a little bit ago, since the lines are congruent, since the lines are parallel, then the angles are congruent. All right, great. Now, next step. Why is 4 equal to 3? Why are those two things congruent? Well, that's from last unit. That's vertical angles theorem. And theorem can be abbreviated THM. Okay, so 4 and 3 are congruent. Well, if 4 and 3 are congruent, back up. If 1 and 4 are congruent, and then 4 and 3 are congruent, well, then 1 and 3 are congruent by the transitive property. If 1 is equal to 4 and 4 is equal to 3, the transitive property says 1 is equal to 3. Well, 1 and 3 are alternate interior angles. Therefore, we've proven this theorem. Okay. Again, you're not going to have to do that full proof. I want you to see and follow from step 1 to step 4 how we were able to justify that theorem. Last one, well, last theorem, and then there's a couple problems. Same side interior angles theorem. If a transversal intersects two parallel lines, then same side interior angles are not congruent this time. They are supplementary. Okay, which means angle 1 and angle 2 add up to 180. We're trying to prove that here. Again, once I prove it, we can just use it. So I gave you that A and B were parallel. 1 and 3 are congruent by the corresponding angles postulate. Okay, 3 plus 2 are congruent because of angle addition postulate. Okay, which says that if I have a line, which I do, angles 2 and 3 make a line. They're adjacent and they form a line. It means they add up to 180. Well, if I replace, since 1 and 3 are congruent, I can put 1 in place of 3. And that would give me 1 plus 2 is 180. And that is a substitution. And now I've just proven that the two same side interior angles will always add to 180. Okay. Now, two little problems here. Notice how the first property is a postulate while the other two are theorems. The difference is that a theorem is able to be proven, which is what I just did. I just proved both of the theorems. While postulate is just accepted as fact. We don't have to prove it. We can just accept it. Okay. All right. Some examples here. This first one is tricky. Notice the parallel lines. You should always make note of the parallel lines. I like to extend them here at the beginning because it then shows I've actually got two transversals here. I'm going to do one transversal in blue and I'm going to do the other transversal in green. So I've got two transversals going on here. Okay. So this can definitely get a little tricky to see. So let's look at X. Well, X is made by the green transversal that I had, the horizontal one. Okay. I look at it and I see that this is 70. Those are corresponding angles. Okay, on the same side of the intersection. All right. So what do I know about corresponding angles? If made by parallel lines, which they are, they're congruent. So X equals 70. Now, Y, you could do a bunch of different ways. So I'm going to show you one way at least. Okay, I see that this intersection, that X plus 50 plus y makes a line. Those three angles together make a line, so they add up to 180. But I already know x is 70, so I'm going to substitute. So together, 70 and 50 is 120. What's left to make 180 would be 60. Are there other ways? Yes. Let me erase. Actually, I'm just going to clear everything real quick and show you that angle and that angle. Okay. Are same side interior angles made by those two parallel lines and this transversal. Now I know that 50 and y together are those are two separate angles that make one angle. So 50 plus y, and then 70 is, those are same side interior angles. And if those are same side interior angles, they add up to 180. And you should see that I'm getting the exact same equation that I had with the previous way of doing it. Okay, you're going to get the same answer. Multiple ways to get to the same answer. All right. The last example, find the values of the variables. Okay. A lot of people are going to start looking at it and say, okay, those are alternate interior angles. So 15x plus 7 equals 18x minus 14. Problem is, you're assuming something that hasn't been shown yet. Okay. That right there, that equation is only true when the lines are parallel. Right now, yes, these are still alternate interior angles. They are. However, there's no relationship because the lines are not parallel. There's nothing that shows the lines are parallel. So I can't find x at this point. Okay. All right. That's it for lesson 1. I know it's a lot. I know it's probably confusing, but hopefully we'll get some time to clear it up. So that's it.